Good day, listeners, learners, students all over the world. For our today mathematics online class, we shall be discussing about calculus. You know, in my previous class, I discussed about the concept of calculus, and I was able to explain those branches of calculus where we have our differential calculus and our integral calculus respectively. So this is the arithmetical aspect of it. There is a calculation. Now, going by this, we have JAMB-based questions. These are extractions from JAMB exams, right? So we have differential calculus. So all these questions that I'm about to address are extractions from differential calculus. They all belong to differential calculus, not an integration or integral calculus. Now we have 5 questions at hand. Question number figure 1, 2, 3, 4, and 5. So here we go. We are asked to find the derivation of the following, right? So we need to follow process. Is that taken? Now we have number 1, which is from my figure 1 to be this. Now don't forget what I told you, that our differential calculus has to do with the study of change, right? You know, whenever you want to have the derivation or you want to get the derivation of a particular function, you will need to work in accordance to the variable given to you. Now look at this. Now we have 2 variables here, which are x and y. Is that taken? But in this Roman figure 2, we have p and q. Am I communicating? So we have p and q. Is that taken? So we have p and q. Pardon. All right. So, however, what we are going to do to this is that for us to get our dy dx of Roman figure 1, we have dy dx. Is that taken? Now, based on the template that I gave to us as our model for us to solve our differential calculus, you will discover that I said that the derivation of this is just like you writing, let me write it here, it's just like you writing our a n, you know, n minus 1. Okay, so we have our n here times, this is the model that we are to follow. Is that taken? For us to get our derivation. So in actual sense, this our 3x represents a. Is that taken? 3x represents a, 5x represents a. Is that taken? So the same thing as this q2, q represents a, 4q represents a, 2q represents a. Is that taken? Now we now move to our n. This is our n, which is the power. The 2 here represents n. Is that taken? You know that the 2 here, which is n, this n is this. Is that taken? So in actual sense, what we are going to do is that we will use this 2 to multiply this 3. It's going to be 2 times 3. Okay, you bracket. We have our bracket. We have x, isn't it? You bracket as well, and the power, which is 2, right, minus 1, based on this template given to us. I mean this example or this model. Am I communicating? Now from this end, we can say that our dy dx is equal to 2 times 3. That is 2 times 3. It will give us 6, right? And we have our x, the power, which is n, which is 2, isn't it? 2 minus 1, that is 1. Is that taken? So you proceed with the second one. The power of this 5x is 1, but it is invisible. Am I communicating? So in actual sense, you will need to use this 1 to multiply this 5. It's going to give you 5. Okay, it's going to give you 5. And this one, okay, let me write it this way. 5, you know, open bracket, x power is 0. You know that anything that is raised to power 0 is what? Is 1. So therefore 1 times this 5, it will give you 5. So our actual answer here is dy dx for our Roman figure 1 is going to be 6x plus 5. This is the actual answer. Do you understand it? So that is how it goes. Now we now move to number 2. Based on what I said at the inception of this discussion, that you need to work in accordance to your variable given to you. Now look at this now. We are given p and q. These are 2 variables. So we are going to say that the p is not the y this time around. Am I communicating? So we have the p, the q, all right? We follow this process, the process from our figure 1. Is that taken? The p, the q is equal to 3 times this invisible one. We have 3 times 1. There is an invisible 1 here. as the coefficient of q. Is that taken? So you bracket, you put your q here, okay, and then we are going to write 3 minus 1 here. So we have minus here as the basic operation. So you write 2 times 4, you bracket as well, you put a bracket here. This is 2 minus 1. This is plus. Is that taken? So this is, there is an invisible one here. So this is 1 times 2, open bracket, then you put your q here. Invisible one, 1 minus 1. Is that taken? So the next procedure, the p, the q is equal to 3 times 1, 3. So we have 3, we have q, 2, 3 minus 1. That is the power, is going to be 2 minus 2 times 4. This is 8. This is q, all right? And 2 minus 1, this is 1. You didn't need to put your 1 there. Is that taken? And then you may put 1 there as well. So we also have plus 1 times 2, that is 2, all right? And this is q, right? Power 0. Anything raised to power 0 is what? Is 1. So we have the p, the q is going to be 3q power 2 minus 8q plus 2. Is that taken? So this is the final answer for our question number 2. Is that taken? So this is the final answer, right? So we have it to be this. Am I communicating? So why this is the final answer for question number 1, that is the y, the s of this function. This is the answer. And the p, the q of this function, this is the answer. Am I communicating? So we now proceed to Roman figure 3. Now for our Roman figure 3, we have the g all over the h, because we have two variables, we have g and h. So the derivation of this our g is this. Is it that you write it this way, or you may write it this way? G, you put your prime there. Is that taken? So this is 4 times 2, that is 8. We have h, okay, 4 minus 1. You follow the process. 4 minus 1, that is the power, is going to give us 3. So this is minus 3 times 6. This is 18. Okay, so 18 times h, that is 18h. 3 minus 1, that is power 2. So plus 2 times 3, we have 6h. 2 minus 1, that is 1. You need to write your 1 there, and then you may put 1 there anyhow. So we also have our 1, invisible 1, times 9. This is 9, okay? So 9, and we have our g, power 0. Is that taken? So therefore the g, the h is equal to the h or g prime is equal to 8h power 3 minus 18h power 2 plus 6h, plus 9, because anything raised to power is 0 is 1, and 1 times 9 is going to give us 9. Is that taken? So that's it. So we now move to the next question. So this is the answer for our question number 3. So question number 4, we move to the next question, which is this. Is that taken? So you can see that this is a fraction from, but it is very simple. So what you are going to do in that sense is that you are to rewrite it like this. So it's going to be y is equal to x power -1. Is that taken? Now you will still need to follow the process. We are having two variables here, which are y and x. So we are going to say that the y, the x, okay, is equal to the y dx, or y prime is equal to, so we have the same procedure. So this is minus 1 times invisible 1. You put a 1 here, okay, open bracket, x. This is minus 1 minus 1. Is that taken? So therefore we can have our dy dx, or y prime is equal to 1 times 1 is going to be minus 1. Is that taken? So we have minus 1, open bracket, x. Then we have the power, which is minus 2. So however, we can have our minus 1 times x is going to be minus x, okay? So this is minus 2, okay? So we can have an answer like this, or you may write 1, which is 1, okay, minus 1 times, we have 1 over x power 2. So therefore we can have our dy dx to be minus